Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/Linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macy, and today I'm interviewing Emeli Dral about monitoring machine learning models in production with Evidently. So, Emeli, can you start by introducing yourself?
First of all, thank you so much for the invitation. I'm really enjoying. My name is Emeli. I'm CTO and co-founder of Evidently AI. This is the startup where we build a tool to analyze and validate machine learning models in production. And prior to it, I worked for 7 years, helping companies from different industries, varying from banking and telecommunication to industries like manufacturing, building database products, and deploying them to production.
And do you remember how you first got introduced to Python?
Yeah, I guess I remember. It happened when I was studying at the Yandex School of Data. Yandex is somewhat like Google of Russia. And yes, at the time I was coding C++, so I did not really enjoy Python at the time. But later on, I got the idea and the power and the beauty of Python. And yes, now I'm not complaining on dynamic typing and things like this. And yes, now I really enjoy the language.
And you mentioned that you're currently running the Evidently AI business and that you helped to found the company. I'm wondering if you can just give a bit of an overview about what it is that you're building there and some of the story behind how it came about and what it is about machine learning monitoring that made you want to focus your time and energy on that.
Prior to Evidently, I'm working at Yandex Data Factory, which is a Yandex department which helped companies build database products. I mean, they help to build prediction services, some recommender systems, and things like this. And it was quite interesting and nice to build the service. And when you just start to deploy the service into production, you need actually to guarantee very nice quality and SLA and things like this. And for many companies, it was a closed perimeter, so we didn't really have an access to the services we moved into production. And yes, models started to degrade, the error increased, the quality sometimes were getting really worse. And at that time, we started thinking about monitoring because, well, we understood that there are a lot of different things and issues that can happen with the models since you move into production. And at that time, we just started thinking about monitoring for machine learning models and about some specific metrics and statistics that we should add to make sure that models work really well. And later on, we, together with Elena, who also worked at Yandex Data Factories for many years, we decided to start our startup for helping out manufacturing companies and build data products. And yeah, there we figure out that it's even more important because, well, you optimize pretty complicated processes and they almost always have this closed perimeter. There we felt this problem ourselves, that we really need to have some tools to monitor and analyze and make sure that everything works. And after it, we decided to monitor machine learning model in open source.
In terms of monitoring machine learning, there's, I know, a number of different aspects that go into that. And I'm wondering if you can just give a bit of an overview about the types of metrics that you're focusing on when you're monitoring machine learning and how that might compare to sort of traditional application monitoring that people might be familiar with from deploying web applications or things of that nature.
First of all, I kind of agree that if we are talking about database service, it's a service at the first place, right? So we definitely should start from service health monitoring metrics like response time, memory usage, CPU usage, and things like this that we are used to in any production services. But together, these metrics, when it comes to data products, we have a lot of things related to data. And I believe there are 4 the most important things that we need to monitor. And first is data quality, because, well, everybody knows that if we have garbage in, we will have garbage out. So it's important to make sure that the input is correct and everything is within the expected ranges, in the expected formats, and things like this. The second, I believe, we need to make sure that the environment, which is what our models communicate, is still the same compared to the data we trained model on. And here we have data drift and concept drift. These are the metrics that helps us to compare the distributions of features, the distributions of targets if we have several, the data we have during the training, and make sure that model continues operates in the same environment with the same distributions and dependencies and patterns, so we can continue use the model. It's especially important when we do not have a feedback or we have a feedback with the delay, so we cannot calculate the error straightforward. In these cases, this data drift and concept drift should serve as an early monitoring, and from this point of view, it's a pretty important metric to monitor. And yeah, basically the first one is performance. In most cases, this is error-based, and if we have a feedback loop, if we can get the ground truth data, comparably small delay, then definitely we need to calculate model's error to make sure that model does not tend to, for example, overestimate or underestimate our target. Yeah, I believe this is for the most important things. And of course, yes, for each case, there are some specific metrics that are pretty relevant to this case. For example, if you're talking about healthcare or social services, there we can monitor things like quality by segments, quality for some specific or low underrepresented segments, because, well, it's very important and we cannot just analyze the model's performance in general. We need to make sure that we account to all needs for all segments of our audience. Or maybe sometimes we need to specifically focus on anomaly detection and outliers, especially when it's critical service. And we can, for example, send some objects to manual review if we cannot guarantee the high quality of our model for these objects. Or maybe some information about some metrics related to biases, shifts, explanations, or things like this. So yeah, for some cases, we definitely can add a lot of specifics, but I believe that we need to have some pragmatic approach and first start thinking about service criticality, and if it's not that critical, then maybe limit ourselves to service health and data quality, data drift monitoring. If service is more critical, then add more and more and more depending on the case.
Another interesting aspect of monitoring for machine learning models is that, especially if you're using them for predictive purposes, there's some measure of subjectivity and built-in potential for error. Whereas with, calculating the amount of memory used by a web service, it's very objective. There's no question about what the number is going to actually mean. And so I'm wondering how you actually account for determining what the error rate is for a prediction that might not have happened yet.
Yeah, this is a very nice question. And honestly, we spent a lot of time defining our thresholds and sensitivity and things like this because we have a lot of defaults in our tool, right? So, for example, one can run the report without specifying any metrics and thresholds, and it will be calculated as well. So I believe the best way to determine all these thresholds is to analyze historical data and try to connect the model's error with the failure costs. For example, if your model overpredict something you spend or you lose this amount of money, is if overpredict then this amount of money, and try to make sure that you penalize your model, or maybe that you send an alarm only if it really makes sense. So I believe this connection between the business losses and model errors is very important. It's not always that easy to create this connection, but in most cases, if an analyst sit together with the manager and they discuss how actually the model's error influence the business processes, what decisions are made on top of model's output, and how actually it influences the whole quality metrics, then I believe it's possible. Yes, we always have historical data, so we can simulate things. We can simulate higher errors, lower errors, things like this, and see how it influences on the process and design on the thresholds. Yeah, I believe it's the way how it can be done.
To your point of bringing in the business users to determining what some of these thresholds are, that also introduces another point of divergence from traditional server monitoring, where that was largely the domain of the operations people or maybe developers, and the business users might only care about the time that it takes for a page to load. Whereas with machine learning, there is a lot of business logic and specifics to the organization's needs and wants that goes into the creation of that model and the whole reason that the model is being deployed. And so I'm wondering how that influences the types of metrics that you're collecting, the ways that you present that, and just some of the overall design and accessibility of the tool that you're building for being able to monitor these models in production.
there is a huge difference between the metrics that you just measure and metrics that you first design how to calculate, right? Because, well, for all the statistical tests, we need to select the window for calculation. We need to select some sensitivity and actually a test, right? Because there are a lot of different tests that suits for example, a numeric distributions comparison, right? So I believe that one should invest into historical data analysis a lot because, well, it's free, right? I mean, if you made some mistakes or come up with the unsuitable window length or something like this, you can always try another variables and parameters and recalculate it until you are satisfied with the result, right? So I think that the importance of historical data is a bit underestimated, and we even wrote a blog about it, so how we can decide on the monitoring settings on top of the historical data. And yes, how I suggest to tackle it is that first analyze your historical data, select all the events or issues or moments where you wanted to get alarm, right? So just label your events as the dangerous potentially or just dangerous, and then create the monitoring in a way that for all these events you would get the alarm. And yeah, so do something like this. I mean, the historical data is the very nice tool to analyze the quality of your monitoring schema and make it maybe more strict or less strict, and to check if it suits. Because, well, if your monitoring does not catch the things that you would like to catch on the historical data, same will happen in production. So this is the nice way how we can make sure that we do not overload our engineers with the wrong alarms and that we catch really important things. So I believe the schema should be tested on the historical data. And when it comes to different kinds of metric, I mean business metrics, engineering metrics, right, and data science metrics, again, there I suggest to be pragmatic and make sure that we have something like the rules or of how we are going to react on each alarm or each signal, right? And really create metrics and set up alarms only for things that we know how to cope with or how to react on. Yeah, something like this.
And then you mentioned a little bit some of the types of error that might occur, but I'm wondering what are some of the kind of failure modes for a model where with a web application, you can see, is it up or is it down? Is it returning a 503 error or a 200? But with a model, it might not be so clean cut where it might be returning a response and it might be within the error bounds. And, maybe occasionally it's returning outside of the error bounds that you've defined as your thresholds. And I'm just wondering if you can enumerate some of the types of failure modes and how they manifest and how you can identify them to be able to know when to take some sort of corrective action.
So first, I believe the most popular error type is that when data is the wrong quality. So yeah, I believe there might be many different types of errors, but the main three types are the following. So first is the cases where we have the wrong input data. For example, some physical sensors might be broken when we talk about manufacturing, or maybe some changes in CRM system, or just some failures because our data pipelines were implemented incorrectly. And in this case, definitely our model will get as an input data something wrong, and the output also should be wrong. So this is why we need to monitor data quality, actually, right? And this is the most common error. So in most cases, when something wrong with model's output, that's because the input data is wrong. So this is the first type of error I suggest to monitor. It's more data engineering thing, but that's very important, and it's cover like more than half of the issues with the models. So the second big segment of errors is related to cases where the world has changed. For example, some salaries increasing, or the audience of the service has changed, or just the world has changed overnight, like we had with the recent pandemic, right? And like a lot of models just get irrelevant in the moment. For these things, you can monitor data drift and concept drift. And yeah, there is no specific ways to maybe differentiate between continuous data drift and like gradual data drift, right? But it makes a lot of sense to analyze these distributions and make sure that we still have more or less the same data points. It's also not that straightforward moment because, well, when we have a model that operates on top of like hundreds or thousands weak features, and it's really a pretty popular design, then if like amount of few thousand features 20 or even 50 is drifting, it's sometimes tricky because maybe everything is still okay, maybe not. And this is why together with the data drift, it makes a lot of sense to analyze model performance, right? And make sure that the quality, that the error rate is still within the expected ranges. So this is the third type of metrics that makes sense to analyze. And there, when it comes to model errors, right, you mentioned there are some cases where object can have higher error, maybe this object can have a lower error, and it's really complicated to make sure that, yes, this is the moment where our model became irrelevant. But what we definitely can do there is try to separate the data drift from the anomalies and outliers. Yeah, there is a completely different things because outlier or anomaly, it's the single event, right? So it might happen for various of reasons. Again, maybe some mistakes in data or maybe some broken sensors or something like this. But in most cases, this is something that's related to maybe one or a couple or three objects. And it doesn't necessarily mean that there is something wrong with our model generally. So in most cases, we can just solve it on the object level, right, and not change anything in our model. But when it comes to data drift, then we definitely need to think about model's quality. Maybe we need to perform some calibration, maybe refit the model, maybe completely rebuild using different training schema, maybe using less historical data to make sure that model do not train on top of the irrelevant old patterns and account to new changes in the data. And yes, that's how we can choose different strategy on top of the results of analysis. So yeah, I would suggest to monitor these three things: data quality, data and target drift, and model's performance.
In terms of the tool that you're building, I'm wondering if you can give a bit of an overview about the design and implementation of the Evidently project and some of the ways that the architecture has changed or evolved since you first began working on it.
Yeah, sure. Actually, we are pretty young, so this is why I believe we do not reach yet our final architecture. And yeah, I believe many projects can say the same. Yes, but it started from more monolith schema. We had at this time only dashboard. So yeah, I believe I need to say that our tool helps analysts and engineers build reports related to data quality and models quality. For data quality, we have data drift and target drift, so-called concept drift. And for models quality, we have a lot of reports suitable for different kind of models, like binary classification, multi-class classification, regression. From the very beginning, we had only dashboard, which are HTML dashboard available inside of Jupyter Notebook. A lot of data scientists like. So this is why it's convenient. And also it's possible to import this HTML report as a separate file to send it over to colleagues or managers or someone who is also interested in the model's quality. And later on, after we speak to a lot of our potential users who just try our tools, we figure out that it's pretty interesting to see and analyze such reports. But for production usage, we need something more suitable to be integrated with some databases and monitoring tools like Zabbix or Grafana. And this is why later we decided to create the JSON-based profiles. And this was the exact moment where we rethink our architecture and figure out that we need to create more models and maybe add an extra layer to make sure that we can split the data representation and the visual representation of our reports. And now we have more layers. Basically, we have three different layers. So first is the analyzers. This is the classes that calculate some statistical metrics, quality metrics, and compare pandas data frames. The second is tabs or report parts. So this is the parts where we combine the results from different analyzers all together and create the meaningful part of reports. And the last layer is the layer of representation. There we have class that generates dashboards, HTML dashboards or JSON profiles. So now it became more modular, and now it's much easier to change something, to add things, to add new analyzers or change structures of the reports. And yes, definitely I wish we had it from the very beginning. That's I believe it's really rare when you start from the right architecture. And yeah, now I'm thinking more about adding some maybe more layers or some modules to add some scalability. Now our tool is impossible to run in a distributed mode, but it turns out that it's pretty important for many of our users because they have pretty huge data sets. Even if you talk about tabular data, still they are pretty huge. And now it's possible to run our tool, for example, in Hadoop or using MapReduce as well. And now we are thinking about maybe some redesign or adding some functionality to make it possible.
In terms of actually running evidently and integrating it with your deployment system and being able to do continuous monitoring of a machine learning model as it interacts with the real world, I'm wondering if you can talk through some of the setup that's involved and some of the supporting systems that are necessary for being able to collect and analyze those metrics over time.
Sure. I will probably start from data because it turns out that not every company who uses machine learning actually logs enough data about it. So first, I would suggest to think about the amount of events and data you are logging and make sure that you log all the input data that your model uses as the input features, right? And the model's output. So this will be essential just to be able to create and calculate all these metrics like drift analysis and models quality. So yeah, this is the most important things. And yeah, from the very beginning, it makes sense to invest in this part because, well, it's historical data and it's impossible to like recalculate it back, right? If you haven't collected it before, then it's no chances to like redo it later. So yeah, this is the first things. And of course, if you have some ground truth or feedback, collect this as well. So not just input data and models output, but also some feedback from the systems that uses the models output as an input. So this would be a first step. And yeah, make sure that you store this data for pretty long period of time. Our tool is now works much better with the batch models just because we are in the development process right now, and the tool is report based, right? And it comes to report, it's much easier to apply it to batch models. So there are many ways how we can call and create the report using Evidently. First, of course, in Jupyter Notebook. This is something that data scientists like to do a lot, but it's not really the best way when it comes to monitoring, right? But yeah, I know that some companies have code in Jupyter Notebook working in production, but it's, I believe, very, very, very few companies. So yes, and this is how we have the command line interface, which also helps to create the reports. So I believe for building the production grade system for batch models, it's better to use it this way. Or you're familiar with some workflow managers like Airflow, and I'm personally a huge fan of Airflow now. So then I can either use a Python operator and call our reports from Python, or just from Bash using a command line interface. So yeah, first is data. Second is evidently from command line interface or together with some workflow manager. Then schedule the calculation of the reports, for example, once a day or once a week or every hour. It depends on the data granularity and some delays in data collection, right? So it can be scheduled by some events. For example, when the new bunch of data came, then we can start calculating the reports. Workflow manager will help a lot calculate it in the right moment. Then decide on what should happen after we created data, because, for example, there are many scenarios which are possible. So first is just use Evidently to calculate metrics, then create the output in the JSON format, right? And having this JSON format, we can integrate, we can plug in this data to some database, for example, Prometheus or PostgreSQL or SQL database, right? So any database is suitable for the project. And then having this data into database, it's fairly easy to use some monitoring systems, again, like Grafana, because it's very popular, or maybe Zabbix. It's also a very nice tool. So this is one way of integration. Another way, which I also like, is to combine the JSON monitoring with help of Evidently with the HTML reports, because HTML reports are interactive. You can analyze each plot. You can do zoom in, zoom out, select some objects, analyze the segments of load performance. So it's pretty nice to generate such reports when you see that there is something wrong with the data and you need to like dig deeper to figure out what has happened. Do we tend to underestimate or overestimate the demand? Because well, we have the error distributions, some statistical tests, so many things that can help to figure out what is actually happening with the model. So I would suggest to use the JSON output to monitor things and create some triggers. And if some trigger worked, then generate the HTML report and send it over by mail, for example, to analysts to help him or her figure out what is happening. So I believe this will be the best architecture. And when it comes to tools, just select the workflow manager that you like. For example, I like Airflow, but there is a bunch of another workflow manager. So starting from something simple as Chrome and maybe Luigi or something like this, and schedule the creation of Evidently. Then select the database where you want to store all this data related to quality of model, and then finish with some monitoring tool like Grafana or Zabbix to make sure that you can visualize all the results, send alarms, and send the report to someone who can fix the model.
In terms of actually building your model, one of the things that you mentioned is that getting it deployed, most people don't collect enough information about the inputs that are going into it and the types of outputs it's producing to be able to effectively determine what its performance is and whether it's, operating as it's intended to. And I'm wondering if there are any other aspects of the model building or model deployment process that you think can and should be improved to make it easier to monitor the models in production and identify how they're performing or when they might be hitting error cases.
I think when it comes to some data that we collect, some logging, the information about data, about input data and output data should be more or less enough. But in case the model use some external data, for example, data about weather, maybe some news data or something like this, it also makes sense to collect this information also. So this is the information about the environment or some external data that we can use as an input. And maybe if the model somehow communicate a lot of external services, then maybe some information about how the services process the output of the model. And let me expand this thought because I believe it sounded a bit too general. For example, I worked on the system that helped to the factory optimize the usage of raw materials to produce the metal, the steel. And we created the recommender system that recommended the amount of raw material to use for each steel smelting, but sometimes these recommendations were just ignored and did not used. So I believe that if the output of your model is interacted with some other systems, it's important to make sure that the system actually used the output of your model. Maybe the system somehow post-processed this output, or maybe it was some fallbacks that worked, and instead of your model's output, the system worked with some another system like just statistics or first principle model or something like this, because for machine learning models, when it comes to production services, it's very often machine learning models combines with the first principle models or some statistics to make sure that the whole service work reliable, and we have some fallbacks in case, for example, we do not have enough data to generate the reliable output with help of the machine learning model. So in this case, it's important not only log the input data and output data, but also log what backend is answered, were there any post-processing from the next level system, and what was the maybe result recommendation or a final forecast or something like this, because very often it helps to figure out the whole service quality much better and see some segments where, for example, the machine learning model works worse than first principle models, or vice versa, or maybe detect some segments of low performance where we need to maybe substitute our model with another model, or maybe retrain it to this specific segment, or collect more data, label more data, and again, retrain model to make sure that we catch all the patterns related to the specific segment, right? So such things are not that important during the general monitoring, but when something goes wrong and we need to figure out what exactly and why, it really helps to analyze and easier find the reasons and connections between the final business process quality and model's output.
Once you identify that there is an issue with the model, what is the process for actually remediating that problem and getting a new version built and deployed into production? And then specifically for the case where the training process might take a long time and there is some critical issue with how the model is currently operating, what are some steps for being able to remediate those problems until you're able to get the new version out?
That's really, I believe, the huge issues nowadays, because, nowadays more and more models start working in the production critical for optimize production critical processes, right? And now, yes, it's pretty hard to come up with the ideal schema of how to retrain these models and to make sure that they operate really well. So I believe that it really makes a lot of sense to figure out at the very beginning of the project whether this model is a part of the very critical service or not, because if it is, then I would suggest to invest a lot of time into automation. I mean, first of all, of course, setting up the monitoring system, then maybe write some code to automatical model retraining. I mean, collecting the new data set on the go and setting up some triggers to detect the moment where we need to retrain our model. And this is actually not that straightforward because, well, if, for example, model quality decreased, right, it might seem like this is the right moment to retrain model. But if we collected only a few amounts of data, for example, like only 100 new lines of the data, this might make no sense because, well, they can have a very small influence on the model training process, right? So there are a lot of different aspects that should be taken into account for the retraining. This is the model's performance, the amount of new data you have, do you have the labels for this data or not? So things like this. And I believe if we're talking about the critical service, then we need to make sure that we implemented the data collection system correctly, that we implemented the retraining process, that we can actually automatically analyze the model's quality, for example, using some golden data set or maybe having some expectations on the model's output distribution or stuff like this. So some metrics with the expected values for them and the system to switch between the models, but this is more technical issues. I believe the software engineers can help with this. Yeah, so for critical services, I recommend something like this. But when it really takes a lot of time to retrain model, sometimes it's not that easy to make it automatically in real time, because in most cases, when it takes a lot of time, it means that the dataset structure and amount of data that we use for training is pretty huge. And sometimes we really need to think before starting this retraining process, because sometimes it makes sense to completely rebuild the model, maybe running some experiments with different algorithms and maybe different pre-processing schema, different feature engineering, or even some hybrid models where, for example, we combine different algorithms like maybe linear models and gradient boostings or something like this. So I would invest the biggest amount of time into scheduling the monitoring that helps you to figure out why exactly the model's quality decrease. Is this the data issue? Is this just some outliers that came to our system and maybe an hour later everything will be fine? Or this is really something wrong with the model. For example, some pipelines was broken or something like this. Because when you see not only the decreasing accuracy or maybe increasing error rate, but you understand what might be the reason for this, you can be more flexible into deciding of what to do and how to react. So to be able to optimize some critical processes with help of machine learning, definitely needed to have this solid monitoring schema, maybe some tools to retraining, and some fallbacks, because, well, when models start behave somehow weirdly and start generate some not reliable output, it makes sense to switch another system and not another machine learning model. Often it's better to be some system that was built on other principles, like maybe really some analytical models, some maybe human-based system, right? So some rule-based system, something like this. And these fallbacks are super helpful, especially at the very beginning when you do not know what to expect, right? Yeah, I think it will have monitoring, fallback system, training schema, and maybe automation and some validation schema to make sure that your newly trained model good enough to be automatically deployed into production.
And then in terms of the alerting based on the monitoring that you're generating from Evidently, I'm wondering what you have seen as some of the strategies for the urgency of the alert, who's responsible for receiving and acting on those alerts, and just some of the process of actually operationalizing and treating these models as a production grade asset, and the necessity for having them be able to operate sort of on a 24/7 basis.
Unfortunately, for now, it's really hard to answer this because, first of all, we are open source tool and we do not really know about all the cases of usage, right? We cannot really make someone tell us how and when they using the tool. And the second thing is that our tool now is really suited much more to some batch models because, well, for real-time calculations, reports is not really the best way how we can analyze the quality. It's much better to be able to calculate a lot of metrics really fast and push it pass to some visualizations tool, like a monitoring tool, right? So it's really hard to say. For now, I can say that there are a lot of data scientists and analysts who use our model to surprisingly run their experiments and compare the models with each other. We actually did not expect a lot of such usage because, well, we were more about comparing the recent data with current data, right, and make sure that the error is not increasing or something like this. But it turns out that together with this, if you use one model as the reference and another model as the current, you can do something like side-by-side comparison. And it turns out that a lot of data scientists now, at least some of them, are using the tool exactly in this scenario.
And then another interesting aspect of this problem space is the categories of models that you're able to generate these metrics for and monitor for, in terms of things like a more statistical style model where you're building something maybe with scikit-learn or something of that nature, versus a deep learning model, and what you see as being some of the category of metrics or the overall complexity that's involved in monitoring those sort of different categories of models, and where you're at currently with Evidently, and whether you're looking to support just one of those categories or bridge across those styles of model.
Currently, we have pretty simple integration. I mean, to use Evidently to create the report or JSON profile, you only need to come up with the CSV file with the features and sometimes target and prediction if you want to build some performance for it. And when you use the Jupyter notebook or Python, then it needs to be converted, read it in Python and converted to a pandas data frame, right? And from this point of view, it doesn't that important on which tool you use to train this model. You just need to be able to generate this CSV file or pandas data frame. And if I can do this, then you can run Evidently. Just small things there is the size of the data frame or CSV file. If it's CSV file, then in command line interface, we kind of recently released the sampling feature. So you can choose the sampling strategy. It can be some strategy with randomization, and you can select which part of the data of the CSV file we need to use to calculate these reports. And for huge data sets, it actually makes a lot of sense because, well, from statistical point of view, the results will be more or less the same, right? I mean, the statistical tests will not be changed that much if you use the half of your data, if you already have enough to compare distributions. Yes, that's like this. If you have the tabular data with any tool or library to train the model, then you can use Evidently. We have some limitations in terms of the case or problem statement, because now it works only for supervised learning, so we cannot really help a lot with the unsupervised models, like maybe user segmentations or outlier detection or something like this. Well, but yeah, for maybe segmentations or some unsupervised models, someone can still try to run target drift reports to maybe compare the results of different models or something like this. But in most cases, yes, it's for supervised models, and it's either for classification, binary, multi-class, probabilistic, or just labels, and for regression. We do not have any specific reports now for ranking problem or for time series analysis, but for time series, it's possible to run the regression performance sub. It covers really most of metrics and most of quality issues, but we do not have some specific time series things. But we are going to add some. And for now, our tool works for tabular data, but we are going to expand it to different kinds of data later on. So it will be texts and later pictures. But before we move into this direction, we need to solve our issues with scaling, because yes, for tabular data, it's just more cases where your data have smaller sizes. But when it comes to pictures and for texts, it's in most cases really huge data sets that needs to be processed, distributed. And yeah, there we need to update our package quite a lot.
In terms of the business aspects of what you're doing at Evidently, you mentioned that sort of the core project right now is this open source framework for being able to analyze and report on these model metrics. I'm wondering what your overall sort of business strategy is in terms of being able to build on top of that library or some of the additional capabilities that you're looking to provide.
We have several hypotheses there. We still do not know which one will be the best one, but we talk to our users a lot, and this really helps us to develop some view and some vision about it. And first things that we figured out is that we have a lot of users who are actually interested in adding some, let's say, business users features like changing the colors of the reports, adding some logo, single sign-ons, and some specific business metrics. So our first hypothesis is that these features will be paid, but all the technical features related to the quality assessments will be open source. So we really want to create a tool that will be useful and helpful for open source. So open source is not just a small part of some huge solution, it's more vice versa. So I believe that the most important things will be always free and open, but additional features for business users might be paid. And we have second hypothesis, which is related to the deployment. We figured out that the using the tool as a Python library or as a command line tool is not the best way for some, again, business users or some companies who are not want to invest a lot of efforts into generating their own internal data science team. So sometimes they prefer to outsource as much as they can. And for these companies, we are thinking about building cloud solution where they just need to load their data and they will create some services that will help with the analysis, with the monitoring, and with alarms. So yeah, it will be a service-based solution with the Evidently inside.
In terms of the ways that the Evidently project is being used, I'm wondering what you've seen as some of the most interesting or innovative or unexpected applications of it.
Yeah, recently we created Discord channel, and yeah, now a lot of users sometimes write us letters, and the most unexpected thing to me was when one user just wrote that he wanted to use our tool to create a blog because he really likes the visuals, and he asked about some specific pictures, but I was really surprised that the monitoring tool might be used as a way to create visuals for a blog. Most unexpected thing to me. And yeah, I believe my co-founder and CEO, Elena, would answer differently. But yeah, I believe this was unexpected. The most creative way is comparison, side-by-side model comparison, because we even created the tutorial on that after we figured out that our tool can be used in this way.
And in your experience of building the Evidently project and building a business around it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
This is the tough question because we are still learning. I believe we learn every day. But the most tough lesson for me was building open source because this is the first project I built open source, and we kind of used that we first can build something on our own and test it, certify it, let's say, make sure that we like everything, and only after this public it to the whole community and hear for feedback. But when you build something open source, you like share it from the very beginning, and yeah, at the very beginning it was quite just to show the final product with a lot of issues and mistakes and not all scenarios covered. We still have some things with generating reports in Windows because, well, we do not have a big engineering team. So it's literally we together with Elena and one engineer helping us out. But yeah, there are a lot of things that should be implemented and fixed. And at the very beginning, I was thinking that we will have a lot of problems and complainings from the community regarding the product's quality. But it turns out that it actually works vice versa because there were a lot of people who were thinking about the same issues, who were thinking about how to monitor their production models, and we were looking for some open source solutions, and they are super open and happy to share their thoughts about what to monitor, how to monitor, what are most important metrics and what are less. And it's just very, very nice when you can think about the problem that seems very important to you together with someone who actually share the same vision, and you can really benefit a lot from the whole community knowledge. Because, well, I worked on some cases, for example, manufacturing, other people worked in banking, some worked in communication, and we can combine all the issues and things that can happen and integrate all this experience and all this knowledge into one tool. I believe this is super amazing. And this is the most important lesson. Instead of maybe being afraid of showing some imperfect product, it makes sense to show it earlier, get more feedback and build something better and faster.
For people who are looking to be able to understand the performance of their models in production, what are some of the cases where evidently might be the wrong choice, at least currently?
Yeah, there are actually a lot, unfortunately. But yeah, I will start from the cases where from not that production critical cases. So if it's just some pet projects or maybe not these critical processes, then I would suggest to go for service health monitoring at just one or two metrics, so without all statistical analysis and many things inside, because, well, I believe it will be overkill to not super critical cases. Again, for experiments, for models that are used more for fun, let's say, again, I would limit the amount of metric because inevitably we have a lot of statistical tests and a lot of visualizations, and it can just overload the engineers and system administrators to react on this alarm. So I would limit the amount of output for not critical cases. Another thing is the different data types because, well, now we are just working with tabular data, and later on it will be possible to use evidently for text and pictures, but currently it's not the best choice, of course, for these data types. And second is the high load, because we are not optimized for this, but this is definitely something that we are working on, and we'll invest a lot of effort a bit later after we fix all the things with the current issues. So yeah, if there is a high load system, I would wait for a couple of, then come back and test us again.
In terms of your plans for the near to medium term, you mentioned a few features that you're working on building, but what are some of the projects that you're particularly interested in digging into?
Yeah, there are a lot, but the first I need to mention is that now we have a lot of nice defaults and predefined report structure. And for now, it's kind of complicated to change something. For example, add metrics and customize the report structure. And this is the things that users complain actually a lot about. So our first step will be create the very intuitive and simple way to configure the report, maybe using some JSON or YAML configs or something like this. So we are going to think about it and maybe even create some ways how users can write some Python code. I mean, some specific metrics with some specific weights, or maybe metrics related to the main areas where they work in, maybe to add some business metrics to reports. So first, we are going to invest a lot of effort into customization. We believe that having nice defaults is very important for users who are just starting out the monitoring process, and for those users who are not really want to invest a lot of time into this customization. But we definitely have a lot of users who want to customize their monitoring process and reports, and for them, yes, we are going to add a lot of features to help with this. So second will be adding more statistical metrics and tests, because we have pretty huge backlog and plans about it, and this is our strengths. I mean, the metrics, statistics, and the analysis of models performance. And we are going to integrate all this knowledge into our reports, and we are going to increase the amount of reports. So our next probably will be the report that analyzes the data set without the models, without target function and models output, to generate some feedback on data quality, on the potential issues, problems, and things like this. Yeah, so this is if you speak about the algorithms and statistics. And I have a bunch of technical problems to solve. Yeah, it's scaling and distribution. And at some point, we are going to build service. We believe that it will happen soon. And yes, this is the big step for us.
For anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the most recent Suicide Squad movie. I just watched that over the weekend, and it was bizarre and a little over the top, but very entertaining. So worth a shot if you're interested in any of the sort of superhero genre. It was good fun. And so with that, I'll pass it to you, Emeli. Do you have any picks this week?
Actually, I'm impressed. But yeah, for this week, especially for weekends, good question. Oh, actually, I have a lot of very nice lectures and videos related to how I can configure and set up pretty complicated workflows in Airflow, because I want to create some very nice tutorials for our users. So yeah, my picks for this week is Airflow, Workflow Manager, and a lot of tutorials around that.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on helping people understand and address the issues that they will run into when they put their models into production. It's definitely a very interesting problem space and one that is still too little understood. So thank you for all of the time and energy that you're putting into helping people address those situations. So thank you again, and I hope you enjoy the rest of your day.
Thank you so much. I really enjoyed the discussion, and I hope someone will find it maybe useful, maybe just interesting, because this is a hot topic, I believe. Nowadays, a lot of models move into production, so it's just interesting to hear what people think about it, right? And thank you so much for running the discussion. It was very nice. Thank you for your time and for your energy.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.